This is a way to model the problem, and then now we obviously have problem constraints. The first problem we have is that we want a reactive user interface. Okay, so what does it mean? It means that if I edit the documents, I probably don't want to wait for 1 second before seeing actually the result of my edits. I want it to be reactive. And typically we want this to happen around or less than 100 milliseconds. And then we have a physical constraint, which is speed of light, meaning that for information to flow back and forth from two opposite locations in the world, this is going to take 200 milliseconds. This is an idea, okay? So we see that we want a reactive user interface around or less than 100 milliseconds. And at the same time, the time for information to flow back and forth is going to take something like 200 milliseconds. So we've got like some kind of problem. So this problem is not new, obviously, and there is solution for that, which are typically optimistic replication. And we want this to happen concurrently. So what is optimistic replication? This is the idea of having a local replica, a local copy of your documents. In this case, this means that when you are going to make an edit, you are going to apply it directly onto your local version of the documents, okay? So that the edit can be almost instantaneous. And then after, you are going to send the changes to the other people on the network. So, and for the concurrence, the idea is the following. So here I'm showing how locking looks like. So for example, we can consider 2 users. User 1 and user 2 want to edit the document, but they are using locking. So this means that if user 2 wants to edit the document, he will need to wait for user 1 to unlock it. Okay, this is not what we want. What we want is not to have lock, so that it can edit the document at the same time. And if you think about it, this is quite very similar to the way, I guess there is a lot of developer here, that we use system threads, where there was like old techniques, like mutex, for example, and we are all going into favor of compare and swap techniques, typically lock-free architecture. Lock-free architecture has a future, and we need to use less and less mutex. This is exactly some of the same idea.